And so let's start. Welcome everyone to Spark Barcelona. Just I will be quick. You all come here to hear from Holden, not me. But well, I took this snapshot or this slide that I did the March Meetup. There were on the wall, on the globe, around the globe, 168 groups make meetups, 2,000 members. Right now, we are 500, three times more meetups with lots more members. So well, we also have more memberships registered. And normally after Reynold and Holden talk, I did we did when you sign it up on the event, we normally ask this question for giving some information or some insights to you, to the speaker. So well, this time I think that it's because Holden's talk is quite more technical. There's a bit more knowledge on the audience on Spark. And just for you to know that right now we're live. Like, it's the first time we're doing it, but we got a streaming YouTube going on right now. So watch out what you're saying. I want to thank Travit for having us in this venue, and then we're having in the kitchen some beers and pizzas, so we can network a bit, talking to each other, to Holden, and create this valuable network. And for welcoming Travit, Andreu will present who they are, who we are, and I'll give the microphone to Andreu.
So thanks for that. Well, it will be a very, very short talk, just a couple of minutes, couple of slides, just talking about what we do at Strawbit and why are we so excited to contribute to the Spark Meetup. So I'll tell this short love story between Strawbit and Spark. Well, Strawbit is a search engine, like a vertical search engine for classified ads. Our goal is to join and collect all the ads over the net about real estate, job offers, and cars. So you can find all of them just in one click, and you don't have to lose your time on all the sites all over the web. But apart from collecting ads, we also love data, like I'm sure you all do here. And we have a lot of data through it. We have more than 200 million ads and 93 million visits a month. And that's only a part of the data we have. That means like keywords, user subscriptions, user preferences, internal stats, logs, etc. So we started very early to adopt this kind of big data technologies. First we tried with Hadoop and all the related environment, which was really useful. But we finally started working with the Spark that now we are actively using in lots of our projects, and we're creating more and more. So that's pretty much all. I told you it was going to be fast. So yeah, that's the love story between Trout and Spark. And well, now
I'm going to Trout. Thank you, Andrea. So we're here for the talks. Just before having Holden here, I just want to announce you that there's a conference in Barcelona that's happening on December, and we met a guy that is also going to this conference. He works in Swisscom, but he's coming here by himself. And it's not here the slide. Well, I just typed it down because we just received the confirmation. But he's Francois, and he will talk about Spark modeling deep learning with deep learning for J on a mixed cluster like between Yarn and Mesos on double Spark. So I don't know if the title is something like that, but yeah, we'll have it on the 9th of December. And with all that, I just welcome Holden here. Thank you for coming, really.
Yay, Google Slides works still. Okay, awesome. So yeah, I stole this from prof because they made a much nicer intro slide than I normally have. Yours has color, and mine is not normally this fancy. Yeah, this is my normal slide with a cat wearing a unicorn horn. The cat's really pissed off. Just like someone that's going to use structured streaming, they're going to be really pissed off too. But yeah, so thank you so much for having me. It's really nice to be able to come and meet more people that are interested in using Spark and working with Spark. It's always fun. And doing the survey beforehand was really helpful. It's really nice to know what the background is. This is the first meetup that I've been to where they've done that. That was awesome. I'll ask other people to do this too. So yeah, this is Beyond Shuffling, Tips and Tricks for Scaling Spark. And I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist, in case you forget. And I'm a principal software engineer at IBM's Spark Technology Center in San Francisco. And that's what allows me to be here and just sort of go all over the world and talk about Spark and then hack on Spark. And I get bored of spending too much time in the United Lounge, which is a terrible lounge, by the way. Previously, I was at Alpine, Databricks, Google, Foursquare, and some other places. And I'm a co-author of some Spark books. And I have a new one coming out soon that I'll try and get you all to buy because I get royalties and I like paying for coffee. You can follow me on Twitter for a really, really depressed Canadian living in America who's slightly horrified with the world that's happening. It's kind of scary, very scary. The slides from today's talk and most of my other talks are on SlideShare. So if there's like one slide you want to take a picture of, this is probably the one. If you want to pretend to be like business people, we can pretend to be business people and connect on LinkedIn. I don't know what for, but I have a lot of connections and we can business. If anyone knows how to business, please let me know. It's been many years, I still don't know what I'm doing. Then there's my GitHub, it's got some code. It's not super exciting, but if you're interested in testing Spark applications, I've got some stuff on there, and I think you should check it out because testing is important. And then I've got some Spark videos. Most of them are pretty basic, but if you're like, are there any real like hardcore Python users in the house tonight? Okay, for those three of you, there is some videos there, and you can check that out. For the rest of you, there's some videos that are going to be boring, and you can check that out too. Any Elasticsearch people in the house? Okay, for that 0 person, you can check it out. So, okay. Yeah, and so normally I don't have this slide, but just because I feel really sad with what's happening in the world, like I'm trans and queer and Canadian, part of the other community. If you want a hug, because you're feeling really sad with what's been happening in the world, like you can just come up to me at a conference and be like, Holden, I need a hug, and I'll give you a hug. please shower that day. But besides that, like, just like hug and no questions. Yeah. But happy computer things, yay! We can distract ourselves from the terribleness that is the world. Right, so I work at the Spark Technology Center. We do a whole bunch of really awesome stuff around Spark. I mostly focus on the Python and machine learning parts of it, but we've got a really big SQL team, and we also have some people working on a bunch of related projects as well. It's not just contributing to Spark. If you care about testing, I think you should use this library, which I'm the primary author of. There are other libraries, but they weren't written by me. And we have a bunch of Spark committers who are awesome, and we've been doing a whole bunch of stuff in Spark 2.0. And this graph goes from small to big, which means I still have a job. As does the next slide, which strongly implies that my employer does a lot of work in Spark. That's probably true enough. It shows us as doing more work than Databricks, which is interesting, and probably as a result of the metrics that we picked. This is why the slide shows it this way. But I think, like, even if you pick other metrics, like, we'll be in the top 3 or the top 4, and that's pretty cool for a company that wasn't really all that invested in Spark like a year ago. And that's like about as good a sales pitch as I know how to do. So please buy IBM support contracts or mainframes or whatever it is we sell. I like having a job. So yeah, let's go into happy computer things. So I'm hoping you all are excited about Spark. We're going to talk about a bunch of different things with Spark. It's just kind of a grab bag of topics because these are the things that I see come up frequently on sort of the user list or when I'm talking to people. So RDD reuse, sort of considerations for working with key value data. We'll talk about how Spark SQL and the data frame and dataset APIs can be really awesome for performance. And we'll also talk about the places where they're going to let us down and break our hearts, so we don't use them. And we'll talk about other ways to make Spark explode unexpectedly. And then at the end, we'll look at a new API which you shouldn't use yet, but is really exciting and promises to fix all of our problems real soon. And who knows, it might. Probably won't, but it might. We can just think of this as going from this like really pissed off angry cat, it's covered in water, it's going to claw our eyes out, to this really happy unicorn. And in case you can't read this, it says, I can't believe it's not MapReduce. Very important. So I'm hoping you're all nice people. If you object to pictures of cats, you're going to have to ignore pretty much this part of all of my slides, and a lot of the rest of them too. I'm hoping you don't mind pictures of David Hasselhoff. When I gave this talk in Germany once, that didn't go over so well. I don't know why, but I've kept David Hasselhoff because it makes me laugh. And I hope most of you know some about Spark. I know there were a few people that put 0 as their experience background. So I've got like 2 sort of intro-y slides that we'll go over really quickly, but it's not like a sufficient intro, so I'd encourage you to buy one of my previous books, or check out some free YouTube videos. And yeah, are there any people that are still playing Pokemon Go? God damn it. I caught a Mr. Mime and I was really happy because I came to Europe and you can't catch Mr. Mime in North America. But it's okay. It's okay. We'll focus on computers. So what is Spark? I mean, we're here because Spark is fast. It's much faster than Hadoop MapReduce, which is admittedly like saying, hey, what's up? My car is faster than a bicycle. It's not a great comparison, but we do a very good job of being faster than MapReduce. Most people, I think, have historically come to Spark from the, like, I have a MapReduce job, I want to make it faster. Wow, this is a lot of work. Maybe I'll just rewrite my code in Spark sort of world. But lately, I think there's been a lot of people coming, especially from the Python community, who just have these problems which they've been working on, and they know their tools really well. They don't want to give them up, but they have to because the data is just getting too big. They can't solve it on a single machine anymore, so they're forced to learn Spark, which is a lot better than being forced to learn MapReduce. So, yeah. And there's sort of 2 abstractions that we've got. There's RDDs and datasets. We'll look at those 2 really quickly. Yeah. So RDDs are resilient distributed datasets. Please don't confuse them with the thing in Spark called datasets. I don't know why we name things these ways. It's very confusing. But we can think of RDD as a magical collection which takes care of everything for us except when it throws an out-of-memory exception. So it distributes our data across the cluster, and it also distributes our work across the cluster. And it's really awesome. It uses lazy evaluation, so if we do a whole bunch of work and chain it together, it's able to like build this graph and do some optimizations on the graph. So like if we do a map and then a map, it doesn't do two separate jobs. It can put those two jobs together and do it as one. There's data frames, which are the new exciting API. Well, their data sets are the new exciting API. They're the type-safe version of data frames. For the 3 people from the Python community, don't get too excited about data frames. They're not pandas data frames. They don't have all of that functionality, but conceptually they're pretty similar. You can think of them as a cross between an RDD and sort of a SQL table or a pandas data frame. And you'll get confused, but that's about as good an explanation as I can do in 2 minutes. The Spark context is our window into the world of Spark. If you're upgrading from Spark 1.6 to Spark 2.0, so the SQL context has become the Spark session. It's not super important. But cool. So for people coming from the Hadoop ecosystem, this slide, besides not showing up very well contrast-wise, might give you sort of an idea that Spark is more than just the traditional MapReduce stuff, right? In the Hadoop ecosystem, you would normally have like one project for your core execution engine, you'd have a separate project for your SQL engine, and you'd have yet another project for your machine learning APIs. But in Spark, most of these things ship together in a single project. And this has its ups and downs, right? It means that we can't like rapidly iterate on our machine learning algorithms without worrying about the impact we have on the rest of the project. But it also means that like, if you just want something that works and you don't want to spend most of your time connecting system A to system B to system C, Spark gives you a really easy way to sort of take the data that you want to run some SQL on and then maybe later do some machine learning or bring it into the Python space and do whatever you want to do. And in fact, we see there's this structured streaming API which is coming, and it gives us the ability to do sort of SQL-like operations on streaming data, which is exciting and fun. Okay, so that's about as much of an intro as we're going to get. Now let's go look at some code. Yay! Code. So this is, this one's Scala. So we're going to read the file in, right? We're going to compute word count because this is a genuine big data class. Well, not class, but whatever, it's a big data talk. All big data talks must have word count in it by law. I know you must be wondering why everyone uses word count as an example, but otherwise they take away your big data license. And I like having my big data license, so we're going to look at word count. The other reason why word count is like a really common example, which I think is something sometimes overlooked, is that it has these like 2 separate types of operations, right? It has like flat map and map, which are like narrow transformations, which means that the computers, like our workers, can compute the data locally without having to talk to each other a lot. But then when we do this group by key, each computer might have some of the words, but not like all of the words, and so we need to do a shuffle so that we can have all of the words that are the same together. And this involves a lot of network traffic. It's really easy to make a distributed system where these 2 things work and go really, really fast. And it's a little more difficult to make one where this part works and goes really, really fast. This is the part which like tends to be slow. Okay, so we've got our word count. We compute, the number of words. It's kind of boring. We use space tokenization. The number 1, we group them together, and we just compute the sum of our list. And then I'm like, okay, I want to save this out, and I'll send my word count report to my boss because he has really low expectations. But I'm also running on log data, so I care about computing the number of warnings specifically. And this is distinct from the number of times the word warning shows up, because I'm just care about how many lines this word shows up on. So I've got 2 simple things that I'm doing, right? And for Python people, the code looks pretty similar, except instead of underscores, we've got our lambdas with some letters. And it's all pretty much the same thing. Yeah. And I connect back to your Wi-Fi network. We hope Google cached the slides anyways. But so there's a problem with this, right? This cat is about to get wet and pissed off and claw her eyes out like on that first slide. So there were a bunch of people that like said 10 for their experience with Spark. What's the problem with this slide? What am I doing wrong here? Sorry? Okay, yeah, cool. So group by key is definitely a sad thing to do. Is there anything else that I'm doing wrong here as well?
Go over the data twice.
Right, yeah, so that's the other thing. I'm going over the same data twice. And so yeah, so going over the same data twice is something which if you're like a programmer from like a sort of regular single node background, iterating over the same array twice, you're like, yeah, why wouldn't I do that? That's fine. But in Spark, there's this lazy compute model. And what this means is that Spark doesn't do any sort of computation until it gets to an action. So we've got if we go back here and we look at our map and our flat map and our group by key, like Spark isn't doing any work until we actually tell it to save the result out. And at this point, Spark goes, oh, okay, I built like up a graph of these things that's going on. Let me go and compute all of those and I'll save them out. And then it promptly throws away the results so that it can do its next thing for you. But the problem is we come here and we do another action. We ask it to count the number of times this word showed up. And Spark isn't able to sort of see into the future. Since it's not like a compiler or a whole program optimizer, it can only see to the action. It can't see the next action that we're going to do. So if we're going to do multiple actions, we need to give Spark a hand. We need to tell Spark, like, yo, please keep this stuff around for me. Does anyone work in a shared cluster where there's other people running jobs on your machines? Okay, cool. More than the 3 people running Python, thank God. So if you're in a noisy cluster environment like that, you might start to experience preemption, right? So Spark is really awesome because it handles node failure for us, right? Like if we lose some machines as we're doing our work, that's okay. Spark is just going to recompute the data and move along. We don't have to do any special thinking about this. But this is sort of based on the assumption that node failure happens some of the time, but not like all of the time, right? If you're always losing nodes to preemption, you're going to always be recomputing data. And this isn't true for like short jobs, like it's fine, but if you're in a noisy cluster and you've got a job that runs for like 8 hours, there's a really good chance that you're gonna run into problems there. And so you've got sort of 2 options for when you've got like a job that's running 8 hours. If you've got an RDD and it's really super important and you can't lose it, you can checkpoint it. And checkpointing isn't normally what people think of as doing for sort of caching data. It's what you do when you've done so much work that it's difficult for Spark to keep track of this graph that's building up internally. Well, we can also use it as a method of telling Spark, like, this data was super expensive to compute, like, please go and write it out to a bunch of disks on my network, so that if I lose a bunch of machines, I can just go and read it back in, and I don't have to recompute it. And if you're on sort of a more traditional cluster where you occasionally lose some nodes, right, you can just tell Spark, you're like, hey, what's up? Just stick this in memory on the node that's next to you, and it'll be fine. And then in the event that those 2 nodes fail, I mean, you do have to recompute that slice, but it's normally not that big a deal. It's only when you have like a lot of node failures and your data is super expensive to compute. The other catch is, and this part can be a little bit confusing, since checkpointing isn't actually intended for caching, when you checkpoint it, Spark throws out the data. So it's written into disk, but it gets rid of it from memory because it's like, I wrote this out to disk, I can go back to disk to get this if I need this. But if you're using it for sort of caching, you should tell Spark, hey, what's up? Please keep this in memory if you can. So like call persist and then call checkpoint, and Spark will keep the data in memory. And so if you don't experience node failures, it doesn't have to go and read it back from disk. But if you do experience node failures, it can go and read it back from disk if it has to. So considerations for key value data. This is where our group by key becomes sort of sad. How many people would describe themselves as a data engineer? Okay. How many people would describe themselves as a data scientist? 3 people. Are you the 3 running Python? No, I'm curious. Are you?
I don't Python.
Okay, cool. Yay! Okay, so for the data engineers, I think most of us aren't super used to thinking about what the distribution of our data looks like, right? We're coming from a background where it's like, yeah, I put it in the hash map, and then that's cool. I don't have to think about what my key distribution looks like, right? Because generally this works pretty well. But once we start like flipping our data around a bunch, we might find ourselves in the case where we've got a key column which is null, mostly null, right? Like it's 90% nulls because this field just isn't populated, right? And then if we try and do certain operations where all of the data from the same key has to go to the same machine, we're going to run into problems when we try and send 90% of our data to that machine. And the other things are important. It's okay. We'll look at the first one. So yeah, so key skew. So I say zip code for you, postal code. Essentially, key skew happens a lot with just naturally occurring data involving humans. We tend to cluster together a lot in cities. So if you've got like sales data or really public health data or anything, there's a really good chance you're going to have a lot of key skew in your data. And we can group by key will fail for us when we have like pretty much any key skew, any significant key skew. But we can have problems even if group by key isn't exploding. Even if like all of our operations are succeeding, we can run into the situation where our Spark jobs are going to take a lot longer because we have these unbalanced partitions, because we've separated our data out by key, and a lot of the work has to happen on like 3 or 4 of the machines that are responsible for the keys that are just very popular. So how does group by key explode? It's evil. And I think part of what makes group by key evil, just like this cat, is that it sounds safe to a lot of people, right? If you're coming from a database programming background, you're like, so I need to compute the sum, so I group by key, and then I compute the sum. But in Spark, it doesn't behave like you want it to. What it does is it groups all of the records with the same key together into a single record. And then this happens even if we immediately perform a reduction on it. So even if we compute the sum right afterwards. And you might be feeling a little upset with me right now because I told you we made this magical graph and we were going to optimize the hell out of it so you didn't have to worry about stuff. But there's sort of this catch. Spark's magical graph, it can't see inside of our lambda functions, right? It can't see inside of the function that we pass to map or to group by or to reduce. All it knows is it's got these graph of transformations. So it knows it has a map, it knows it has a group by key, but it doesn't know what's happening inside of the map stages, right? So it isn't able to say, you're doing a reduction, I'll just start pipelining this a bit earlier. And then what happens is this is too big to fit in memory and our job fails. And honestly, you're lucky if your job fails because you know that you did something wrong and you fix it. The bad case is where your job succeeds, but it runs really slowly and you're just like, well, whatever. That's okay, I'll push it to prod. And then it fails in prod and you get woken up at 2 o'clock in the morning. And it's I used to carry a pager. It's not fun. But of course, the exception is Spark does have a SQL interface, and if you're using the SQL interface, group by key is actually safe. It behaves like SQL. It's very normal. Don't worry about it. So what does this failure look like? So this is some zip code data in San Francisco. And so I like to pretend that I'm interested in opening an artisanal mustache wax shop for hipsters who have handlebar mustaches. And in the Mission District, there's a lot of people with mustaches. So I'm interested instead of computing, where is the best place going to be to open my mustache wax shop? And so the problem is I called group by key, so I made this record that was too big. There were too many handlebar mustaches in the Mission District for me to be able to know where I should open my mustache box shop. I really need to pick something that I can say more easily, but I like mustache box. But we can see, like, not only does it send all of the records to this one single machine, the record, it makes this like big giant record. So even though Spark can do some tricks to not like load all of the records right at once, it's definitely going to fail because this record is just too big to fit in memory. So what would we do instead, right? So group by key we know is bad already. And the normal version that you see is reduce by key, right? And so reduce by key is, we're doing essentially the same thing. Our result is the same. We're getting the word count because it's big data. But what's happening is we've told Spark, this is the function I want you to apply on all of the values for each of my keys. And so instead of taking all of the values and making one giant record, it takes this and it goes, hey, every time I see something with the same key, I'm just going to take this function and apply it right away. I'm going to reduce this data down as I'm going. And so this is pretty cool because this is run on 48 kilobytes of data. So not genuine big data, but it was on my laptop and it was on the flight. But we can see group by key has like a shuffled read of 48 kilobytes. And so that means we have to send that data over the network. But if we take the same thing and we replace it with a reduce by key, not only does our job like succeed in the future if we start throwing actual big data at it, even when we're at like the smallest data step, our shuffled read is like about the fourth of the size. You just have to trust me because I'm blocking it from you, but I assure you, it actually says these numbers, and I didn't make them in MS Paint. And yeah, so, oh yeah, and then there's a happy puppy as opposed to that sad puppy. So like our code is clearly better when we use reduce by key. And so really, anytime we find ourselves using group by key, we need to ask ourselves if we can be using reduce by key or aggregate by key. And for people from MapReduce, essentially we get what's called a map side reduction for free. That means on each of the workers, before we send the data across the network, we reduce it locally, and then we just send the data there. And so that's why we get this much smaller network traffic. But we can make it fail other ways too. Yay! Sadness. So even if we didn't call group by key, right? Let's say I knew not to do that, but I was like, yeah, I maybe want to see like a sorted list by zip code of, you know, people with handlebar mustaches, so I can figure out where I want to run my direct mailing campaign. We can hit this partition size limit of 2 gigs, which is really kind of silly, but it's still there after years because it turns out fixing it is a lot of work. And every time we get started, we get distracted with adding new shiny features instead of fixing it because new shiny features make people happy, and once they're at the point where they're running into partition size limits, you've pretty much already got them hooked, and they're not going anywhere. Sorry. But it's okay, we can work around this partition size limit. It only exists during the shuffle stage. So like if you have like partitions that you're reading in from disks that are larger than 2 gigs, don't worry, it'll be fine. It's just something in the networking code, I think. But it's okay. So sort by key, sadness, right? Once again, our handlebar mustaches are just too popular in the mission district. We don't get giant records, but we do send more than 2 gigs worth of data to this one machine when we sort it by key. Yeah. But it's okay. There's a really simple fix to this. And we just add some junk to the end of the key. And this is kind of hacky. And the cool thing is, right after you've added this junk to the end of the key and you've done your sort by key, you can do a map where you get rid of this junk, right? And that can be a little bit confusing because like the restriction that made us have this problem is that Spark says like all of my things with the same key have to go into the same partition. And so if I'm telling you that we can like add some junk, but then I can get rid of it afterwards, you're like, wait, like now they have the same key, why don't they all have to go to the same partition? And so this restriction only exists during a shuffle phase, right? So it's okay if we have the same key on different partitions, provided we don't have a known partitioner and we haven't had, like, we're not doing a shuffle phase right now. And so we're not limited to sending everything to one machine. It's just a little hacky that we have to work around it manually instead of it happening automatically for us. But because the partitioners need to be deterministic in Spark, with its current design, it's something we're pretty much stuck with. This is essentially a talk of things that we should have done differently in Spark, but didn't, and how to work around them. So I'm sorry. They're not my fault. Some of them are. And there's some hidden magic inside of the shuffle. Yay! The only slight catch is, like all magic, it's actually made of propane, and will occasionally explode. Yeah. This sculpture, to the best of my knowledge, is very safe, but it's still made with propane. Anyways, so we can reuse shuffle files. And what this means is if we do a sort by key or we do a repartition, Spark implicitly creates these files. And normally, the files never really hit disk. They just live in the memory buffer of the OS page cache. But there's these files, and they exist on the worker nodes. And if you want to go ahead and do a different action that depends on the same shuffled data, so it has, you have two actions on the same RDD. If that RDD was specifically shuffled, you don't necessarily have to cache it. You can depend, sort of, for now, and this will go away once we fix the bug, but for now you could depend on the fact that the shuffle files are there, and they'll be implicitly reused. The only problem is the cache is really intelligently managed. If you ask Spark to cache more things that it can fit in memory, you're not going to get an out-of-memory exception. It uses an LRU cache. It'll just evict some things for you. The problem is there's no real management of the shuffle files. So that hasn't historically been a problem, right? Machines used to just have like terabytes of disks because, whatever, disks were cheap. But then we found out SSDs are really fast. But they don't, terabyte SSDs cost money. So we were like, well, maybe we'll put in like a 512 gig one. And then someone was like, whatever, I'll put in 128. Everything's using RAM nowadays anyways. What could go wrong? Well, these shuffle files can go wrong. We'll make so many temporary shuffle files, we'll fill up your disk on your executors, and then you'll fail with an out-of-disk exception. And you'll be like, what? Wait, but it's in memory. What's going on? I'm really confused. And this is it. Yay! So how do we work around this bug, or feature, depending on your worldview? I know someone that thinks it's a feature. He and I disagree. But so the way that we can work around this is once an RDD goes out of scope on the driver program, it's not immediately collected, right? So we have to trigger a garbage collection event on the driver program. And then when the Java GC goes through and says, oh, these RDDs no longer have references pointing to them, Spark goes and cleans up the shuffle files on the workers at that point in time. And that will work. It's a little bit confusing, and you can run into this problem when you increase the amount of memory in your driver program, because garbage collection will happen less often, and then you'll run out of disk space on your workers, and you'll be like, how are these two things related? And this is how. Software is awesome. I think it's awesome. But you might be like this cat and be like, no, Holden, everything's terrible. Right. Alternatively, if the idea of like depending on the system GC and like calling it in just the right place has you going like, ugh, you can look inside of the ALS code in Spark where we explicitly clean up the shuffle files. It's done with internal APIs, but if you're willing to lie about being inside of Org Apache Spark, you can get access to those same internal APIs. It's just your fault when your code breaks rather than my fault. So, keep that in mind. I wrote those internal APIs, so like it's really your fault and definitely not mine. Just so we're clear. I don't want to deal with those bug reports. Beware of cat. Okay, other things we can do to make Spark fail. I swear after this making Spark fail thing, we'll look at cool things we can do with Spark. I promise. Does anyone use map partitions? 3, 4, okay. So for those of you using map partitions, iterator to iterator transformations are really important. And what this means is map partitions gives you in an iterator, and it expects you to return an iterator. But because Scala is really nice with its type inference, if we return a list, it'll be like, oh yeah, it's okay, I can get an iterator from a list. I got this. The only slight problem is if we give it back a list or something, we've sort of forced Spark to read all of the data in at once, and Spark isn't able to do what's called spilling to disk. And that's when I have too much data to process to just store in memory. I want to spill it out to disk as I'm going. But if I sort of force Spark to make a list or something, then I lose this spilling to disk thing and I get an out of memory exception. And then I'm sad. For those of you that aren't using map partitions, I mean, I just told you why not to use it, but there's some cool things you can do with it. If you have some setup work that you want to share for something, and you need to connect to a database, and you want to reuse that handle amongst all of the elements in that partition. Map partitions is your friend. You can do all sorts of crazy things inside of map partitions. In fact, most of the transformations in Spark are actually implemented using the mapped partitions RDD. So you can build all of Spark's sort of core build. Well, not all. You can build many of Spark's core building blocks using this thing. You can also shoot yourself in the foot. Cool. Yeah, this is David Hasselhoff, I think. I don't know. Maybe the Germans were annoyed because it wasn't David Hasselhoff and I told them it was. But I'm 80% sure this is David Hasselhoff. Yeah, so explosions. Fire. Okay, exciting things. Yay! No one's excited. Okay. So, is anyone using Spark 2.0 yet? Huzzah! It keeps being 3 or 4 people, but it keeps seeming to be a different 3 or 4 people. So this is good, because it means this isn't just really boring for those 3 people. But so datasets are new in Spark 1.6. There is sort of this type-safe version of the data frame API, and starting in Spark 2.0, the data frame API is actually just a subclass of the dataset API. It's actually a type alias, which for Java people means that your life is terrible. But for Scala people, everything's okay, so we can just ignore those Java people. That was the argument on the PR, but whatever. Slightly bitter. Anyways, they make it really easy to intermix functional and relational code. And I really like functional programming, arguably too much. I use functional programming in all sorts of places where it's not the right answer, but it's the answer that I like doing. So I like something which gives me the opportunity to use more functional code, right? Spark is in and of itself a very functional API, but sometimes I have to work with other people that don't share my love of flat map. And that's fine, right? They'll give me some relational style code. But I want to be able to work with them without having to rewrite their code. And I also don't want to have to write UDFs. Has anyone written a Hive UDF? Okay, keep your hands up if you had fun writing a Hive UDF. Really? Damn. Okay. You're the second person ever. We should talk, because I want to understand why. Seriously, no judgment. I'm just curious what you like about them, so I can steal them and use it for things. Sorry, not steal. So they're still experimental, and the API will change a little bit, but it's getting a lot better. So we're going to do word count again, just to make sure I keep my big data license. But here we're going to do word count on CSV data. Yay! So this is how we're going to load some data. It should look pretty similar. This infer schema thing is really cool, though. For CSV data, I mean, it's not exciting, right? Because you're Holden, you just read the header file. That, not impressive. Not impressive. But it's actually really cool. It's really fun. Let's look at why. So it's really fun because one of the supported types is JSON. Does anyone work with JSON data? Anyone, please? Yes! Okay, so people keep giving me JSON data without a schema. When I ask them for a schema, they're like, no, it's JSON. And I'm like, no. So I love Spark because I can point Spark at terabytes of JSON data collected over years, written by 6 different versions of the program, and be like, what the hell is this data? And Spark will sample the data, it'll figure out the it'll figure out the variance, and it'll be like, yeah, this is like probably what the data is, and I can have a schema, and I can actually like reason about my data. Or if I like need to be like super sure, I can be like, yo, Spark, go and read all of that data and tell me for sure what the schema is. And it'll read all of the JSON records. It has rules for like when you've got different types in a place on how to like move the type class up. It's really awesome. I love it. I sometimes even use it on megabytes of data because I'm really lazy and reading JSON is like not a lot of fun. Also, like I know Spark and like hammer nail, or hammer screw. Yeah. It has other supported types too: Parquet, JDBC, Hive. CSV is really simple, but it turns out it's a really common data format for a lot of science work, which is scary. But like whatever, it's better than JSON, maybe. Anyways, and so that's actually moved from Spark packages into Spark Core starting in 2.0. But if you like have Redshift, Mongo, Cassandra, CloudNet, Couchbase, I should really figure out what the IBM databases are called so I can list them here, or any of those things. I know we have people working on them, and damn it, this is on YouTube. Awkward. Anyways, so there's tons of packages for talking to all sorts of different data sources, many of whose names I don't even remember. But if you have a data source, you can probably talk to it with Spark SQL, and that'll be really awesome. So we can load our data, we can inspect the schema if we were given a bunch of JSON data by some people that hate us. Or even like, I mean, they might not hate us, but they like mean well, but they produced some records differently back in 1999 and I forgot about it. We can do like functional transformations, we can do machine learning. If we're at the point where we're just like, yeah, this dataset API is like weird and broken in some way, and you'll find some places where that's the case. It's okay, you can jump into an RDD for free, where free means like mostly free. Please don't time it, but like, yeah, you can pretend it's free. And we can do word count again, yay! I know you're all really, really excited about word count. So that's the one we're gonna focus on. Oh wait, we're gonna look at the schema first. Okay. So this is some JSON data from someone that hates me, but it's about pandas. So I was like, well, I care about pandas, and this one tells me there's a panda in the mission. So like, I'm interested. It turns out that was a lie. My data was, corrupt, but it's okay. So I can get this schema, and I can be like, okay, so this is what my like panda information looks like. And now we can do word count. Yay! Now, come on. At least pretend to be excited about word count. It's like, I'm the one that has to keep putting the smell of my presentation, so they take away my license. Keep pretending it's real. Anyways, so we load our data. We see here that we didn't actually specify like the type, and that's just because it's being inferred for us automatically. We also didn't specify the schema, so the schema is being inferred for us automatically. And I'm saying there's like this one column that I care about, it's called text. I'm going to go ahead and I'm going to compute the word count on this text field. Now this is the data frame API, this isn't the new exciting data set API. And you can tell because there's a lambda and it's definitely Python code. We don't have the new exciting data set API yet, but we can do our word count here with the data frame API. And once we get the data set API, we won't have to do this work to go back into a data frame. We'll just be able to like keep everything inside of a data frame, like the fancy Scala people are able to do right now. Unfortunately, because we use this lambda function, it's a little slow. Part of what's awesome about data frames is they're faster than RDDs for a whole bunch of really cool reasons. But when we did that lambda expression, we made it so Spark had to copy the data from the JVM into the Python VM and back. But it's still faster. We can actually, I think I have some graphs. Oh, okay. The graphs will come later. There's some catches. There's this function called toPandas, which you can use to take a Spark data frame and turn it into a local pandas data frame. It's essentially collect, and it's implemented somewhat naively right now. One of my coworkers is working on making this faster, but for now, toPandas is a little slow. If you have lots of data, you probably can't use it feasibly. Just like with RDDs, I probably should have mentioned this earlier, but we can join data sets and data frames. And as I like to say, the cross product of big data and big data is an out-of-memory exception. And we can accidentally do a cross product when we join something which has the same key repeated all the time. So if we're joining on something where 90% of our thing is null, keyed, and the same thing is true for the other data frame, we're going to produce an out-of-memory exception. And this was supposed to be the happy part of the talk. Oh well, it's okay. There's some sadness inside of all of your happiness. It's okay. Yeah. Okay, yeah, let's go back to happy things. So the fancy Scala people. It's cool. We get to just like write our Scala code. We don't have to like take it back into a data set right afterwards, right? Like we've got this like sort of relational expression. We have the select statement, which is also relational, and then we've got some Scala code. It's like, okay, cool, that's fine. Now the problem is like the Scala code is at the end, and you're like, Holden, that's not that exciting. I could have just turned this into an RDD and called reduce. Like, you haven't saved me any time. And it's true, I haven't. But it's nice, right? But we can do cool things like this. And this is the part that makes me excited. Instead of learning SQL properly, I can write these really fun map statements in the middle of someone else's code. And I can have my arbitrary Scala code in the middle of all of this relational code, and it just gives me back a data set. And it's strongly typed, it's inferred the types for me, and it's awesome. Like someone can go and write a SQL expression on the result, and they could have written a SQL expression on the input, or they could have written a relational query to give me the input. And we can work together without actually having to understand each other, except for the part where I misassume what one of the columns means, and then we cause the next financial crisis. But, you know, ignore that part, and focus on the fact that you can intermix these two coding styles. You should actually talk to your data scientists, data engineers. It's important. I like having a functioning world economy. And it can be so much faster. So we all know group by key is bad at this point. So the fact that the red line is really high should tell us that high means bad. But the blue line is our like reduce by key one. And this is what I told you to do, right? I told you reduce by key was what we should be doing. But we can see that data sets and data frames actually outperform our reduce by key. And they do this even if we're doing the same operation many, many times. We give the Java JVM a chance to like JIT our code and compile the bytecode down. And so even in the case we give the chance, you know, we've got this repetitive task, it's still worth it to try and do it in the data frame API. And there's a whole bunch of reasons, right? There's like a more efficient serialization framework, so it takes less time to like write our data out onto the wire. We can do sorting on serialized data types. We don't have to deserialize them to compare them. Some of the time, there are some restrictions. Not valid in the state of California or whatever it is. But, you know, so it's just faster in general, even than our handwritten code. So that's kind of cool, right? And for the 3 Python users, reduce by key is indeed better than group by key, but it has this like sort of this cost of being executed in Python. But when we're using the data frame API, if what we're doing is really sort of simple and it's mostly relational expressions, these relational expressions will actually be executed inside of the JVM. So like this part is so much lower than the blue line because it's actually running in the JVM and the data isn't having to be copied. And also the JVM tends to be a little bit faster than the Python VM as well, just in general. Don't shoot me. Oh wait, this isn't America. It's okay. But it's going to explode in some places too. Yay! I told you there was going to be some sadness inside of our happiness. So for those of you that are writing your own machine learning algorithms, if you're doing some like iterative gradient descent optimization or something like that, you're going to have this iterative algorithm, or if you're doing like a graph search thing, you're going to end up with these really large plans. And the problem is that the Spark SQL optimizer isn't so great at recognizing that we've got essentially the same plan copied twice with one tiny variable changed a little bit. And it isn't able to say, oh, it's cool, I'll just take the same plan I generated before. It actually goes and analyzes each of those independently. And eventually we'll fix this bug. But for now, if you have an iterative algorithm, there's a trick you need to do that I have on the next slide, or if I don't, it's on my GitHub. If you're just using the machine learning algorithms inside of Spark, don't worry, they already do this trick where necessary. The default shuffle size is a little bit small. Oops. I hope that wasn't important. Okay, cool. So it's 200 partitions. If If you only have like 100 nodes in your cluster, that's probably fine. But if you've got like 1,000 node cluster, you really need to bump up a lot of the defaults for Spark SQL. Similar to how you had to do this with Spark, right? Like you had to bump up the default memory for your executors. There's some knobs that we need to do. So it'll explode, but it's okay. And this is the hack that I was talking about. Don't use the one from my slides, use the one from my GitHub. I don't update my slides as often as I update my GitHub, and people tend to send me pull requests to GitHub rather than Google Doc changes. I don't know why, but whatever. Apparently it's easier to develop code in the text editor. And we can use it for streaming! Yay! Does anyone have streaming data? 3 people again? You're killing me. Come on. Okay, 4. This just hurts. Okay, so for the most of you, this will apparently be useless. But we can be excited about it anyways. For those 4 people that have streaming data, we're going to be super excited for them. I've drank a lot of coffee. So instead of doing the old streaming API where we introduced a new class, we introduced this thing called dstreams, and they were completely, behind the scenes they were RDDs, but it was this completely new class. So like we could reuse some of our code, but we had to like think about it a bit more. Structured streaming just uses the same classes, and it just adds this is streaming Boolean flag to it. So when it's true, it's streaming. Yay! But it's in really, really early stages. And if you have a corporate expense account and are looking for an excuse to visit Singapore, I will be talking about this more in 2 weeks, give or take, in Singapore, possibly in 1 week in Slovenia. If you have a corporate expense account, please come visit me. I like friends. But yeah, so we can use it for streaming. There's going to be some catches. We'll find out about them soon. Right, yeah. So the catch is you shouldn't use it. It's really exciting. The API is really, really cool, and it's totally the future. But the future is notably not today. It is a very important distinction. If you try and use it now, this cat will bite your fingers off. And if you're in the medical industry and you use this, I will find you and be sad at you. Not just sad, sad at you. So please don't use this just yet. If you're listening to a recorded version of this is from 2016. But like, we're good. So don't use this today, but we're going to look at the API anyways because it's going to be probably what we want to use next year. And I don't mean January. Just to be clear. Okay, cool. So this is pretty similar to the API I was showing you earlier where we did word count. You might have a guess about what we're going to be doing again. I think we're not doing word count for a change. Right, yeah, we don't have to have all of our examples be word count, just most of them. So there's this catch where right now we can't infer the schema on streaming data. And that's just because data is showing up sort of incrementally and because we can't like sample from the future. I don't have a time machine yet. I can't figure out what my record variance is going to be in the future. So I have to specify like, these are the fields I'm expecting. And then I call read stream instead of load. And then I specify my schema and I say I've got some per K data streaming in. And then I give it the path. And then it makes this like little data set. And it's like, yay! And it's got this property set to true. This part was made by my coworker, which is why it has colors. And like, fancy colors. But so this part was definitely made by me. I care a lot about coffee. And I believe that coffee is strongly correlated with happiness. But I'm really lazy, and I'm worried that if I use actual machine learning, like if I did a linear regression on it, it might reach incorrect conclusions. So I've decided to sort of selectively evaluate as just the average happiness, because I'm pretty sure that I can, screw up my numbers and make it look like the more coffees I drink, the happier we're all going to be. So we're going to compute this group by the number of coffees and the average happiness. And notably, this is the same API we would use if we wanted to compute how happy people were based on the number of coffees they drank in a batch API, right? This isn't a separate streaming API, this is the same API. And group by is safe because we're in the happy Spark SQL land. I'm not doing terrible things, it's okay. This isn't a trick, the cat is happy. And then we go like, okay, cool, I want to write it out. I say I want to write out my result in 5-second intervals so that I can find the one batch where it said that the more coffees I have, the happier I am, and that's going to be how I publish my paper. For some reason, people don't take my papers, but you know, we've got this batch, and we say like, I want a complete view of the world, so I want to see all of my statistics aggregated each time, not just stuff that's changed, and write it out in 5-second intervals. And now it turns into a query. Ooh. And we can ask the query, you know, is it running? Has it crashed? Like, what's its deal? And for right now, it'll probably say like, yeah, I'm running for like, you know, 3 hours, and then it'll be like, yeah, I don't know what's going on. So like, don't use this in prod, but it's fun. And here is the set of things for why you shouldn't use it. The last time I talked about structured streaming, someone came up to me afterwards and was like, so I want to use this in production. Please don't do that to me. Please, if you're going to use this in production, just don't. Just tell your boss you're working on it and do nothing for 6 months. The world will be better off. So yeah, here's sort of the list of restrictions. We're not going to go through them because they're kind of boring, but this is hopefully enough to convince you that like, this is the future, notably not today. Yeah, cool. So there's a whole bunch of resources related to Spark. Coincidentally, I might be involved with some of them. It's coincidence, I'm sure. Also, sometimes the one that's listed first. I don't know why. So there's like, if anyone cares about testing, there's some really good libraries for testing, and there's some libraries from other people for testing. They're actually very good as well. The SS check person is amazing. If anyone cares about property-based checking, if you like think that, you know, coming up with sample data to test with is like kind of a waste of your time, I really encourage you to check out property-based checking, and you can do it with both of these libraries. But this one is written by someone else, so please use mine. But theirs is very good too. And then Java and Python exist, and I have a talk about testing up on YouTube if you want to check it out. Keep talking about testing because I keep running into people that are like, yeah, I built my code in a notebook, and I deployed it to production, and now it's not working. And I'm like, cool. So were there tests? And they're like, oh, well, but I built it in a notebook. And I'm like, yeah, you need tests still. Notebooks are cool, but they're not magic. Jesse Anderson has a blog post talking about how to do testing with Java. Another person talks about a different library in Python than my library, which is probably legit, because I keep forgetting to update the Python components, just like in real Spark. And so, and there's other really good resources. I keep meaning to do office hours. I used to do them a lot, but then I started traveling a whole bunch because I found out no one asks where I am, and I get to meet all of you wonderful people. But I'm going to try and settle down a bit, and I'll do some Google Hangout office hours in the new year. And if you've got like Spark questions that are like really specific to your use case, and you like don't want to ask them in a talk or something, like, you know, we can hang out then and we can try and figure out like what the deal is. And you can follow me on Twitter. If you can put up with all of my complaints about America, you'll also find out when the office hours are. There's occasionally pictures of cute cats. There's a lot of books on Spark. Relatedly, I may be a co-author of many of them, but I'm going to do the thing which, like, it hurts to do. Please don't buy this book, even though I receive the most royalties for fast data processing with Spark. It is incredibly out of date. I kind of wish the publisher would stop selling it. It's like Spark 0.7, and we're at Spark 2.0.2. If you just like want to give me money and like you don't want to put cash in a brown envelope, you can buy that book. But you could also buy like my other book, which might be useful. And in fact, if you have a corporate expense account, it is the gift of the season. I encourage you to buy several copies of it. Conveniently, it is also the e-gift of the season because it doesn't physically exist yet. So yay, you can give O'Reilly your money, or your employer's money, preferably, and then O'Reilly will give me a slice of your employer's money 3 to 4 months later. And you also get a book. Yeah, but there's good things too. I think it's a fun book, but I'm obviously super biased. it's like, it's not just sad things like this talk. It's like really awesome happy things rather than just like a pile of things you need to work around. It's like, here's some cool ways to solve some cool problems. But don't worry, there's a few chapters which are just like the chapters of sadness. And it's an adventure. We didn't label which ones were sad. You get to find out as you're going. So please, don't read it when you're feeling down and drinking. It'll go poorly. But like, read it when you're in your happy space. If you don't want to give me your employer's money before the book exists for some reason, you can give me your email address to spam when the book does exist. And there's a bunch of videos for people that are new to Spark. I think Paco's introduction to Spark is amazing. He has a YouTube video. He also has a more professionally done O'Reilly video that costs money. And if you have a corporate expense account, I really encourage you to support Paco's awesome work. His work is really good. And if you buy his fancy videos, then Paco gets money. And Paco's also a friend, and sometimes he buys me beer, so it might be a little biased. But I think Paco's work is really good. Yeah, okay, so for the 3 Python people that were hanging out in the audience, I'm really excited about PR number 15659. Oh my god, why am I so excited? Damn it. Okay, it says just got merged. I care about Python a lot. Even though I really like Scala, I like supporting Python users. They're really friendly and they buy me cookies. But they also do a lot of really cool sort of data analytics work that I just am thoroughly unqualified to do. So I can give them tools. And this PR makes it so that you can pip install future versions of PySpark. So if you're working in a Python shop, there's some people who are a little turned off by downloading a tarball, extracting it, setting some random shell variables, and then setting some other shell variables so that they can start a Jupyter notebook. This will hopefully allow you to convince them to join us on the dark side. We have cookies. And so that's pretty much it. Thanks, bye. If you could all pretend to look really happy about this talk, I would love to take a picture so that in case my expense report gets questioned, I'm no, it was really important. I went to Barcelona and I drank a lot of coffee. There were so many awesome people there. It would be terrible if I did not do this. So just give me 1 second and we can pretend. Come on. Oh no, my bad. Okay, sorry. I have 2 phones. One is for Pokemon Go. The other one is also for Pokemon Go. I have a problem. Okay, pretend to be happy. Okay, well, it's about as good as I know. Thank you so much.
You want I can take the picture with the audience. You can show that you're actually...
No, it's okay. This is good enough, so believe me. My expense reports don't question too thoroughly. If that ever happens, it's probably time to find a new job. It's just going to go poorly. Do we want to go downstairs or have questions?
If you have some questions. Questions? No? Well, then let's go downstairs.
Yay, pizza!
Pizza beer. Yeah.
Awesome. Thank you so much for being on.
So, 10 spectators.
Oh, cool.